let's talk about logarithms now. So logarithms are these fun little things that you can use to solve for things. So, say for example you have a number, y. Let's say y is 9. And then you have a base. Let's say the base is 3. Now you're trying to solve for this x here. Now this may seem really easy, but once you get into the bigger numbers, you won't want to just type into your calculator whatever you try to get this y. So the way you can solve for x without typing stuff into your calculator randomly is you just convert it into log form. So the way I like to memorize this is this b is always normally like below everything else. So here it's below the x, and here it's below the y. So I just like to think of the base as being here, and then you just switch these spots here. So log b is 3 here, so 3. Now this is the y and this is the x, so we just swap them. So log base 9 equals x. So you can just plug this into your calculator and it will spit out x equals 2. So logarithms are useful for things that are bigger that you don't want to necessarily multiply out. So let me introduce some logarithmic properties. So we'll start out with a fairly simple one, like log base a of, let's say, b plus log base a of c is the same thing as log base a of bc. That being said, you could just multiply them together into one simple log. So whatever works for addition should also work for subtraction, and whatever works for multiplication should also work for division. So log base a of b plus log base a of, minus log base a of c should equal log base a of b over c. Right? Addition and multiplication, subtraction, and division. So suppose we have a problem like this. Log base a to the x. So with logarithmic equations, functions, you're basically just trying to find what power a should be to get a to the x. So it makes sense that if you draw it out like this. So switching from this form to this form. They call this form logarithmic and this form exponential, by the way. I feel like that should be appropriate to mention here. So this is basically what excuse me, this is saying here. So it only makes sense for this to equal x, because what's going to equal a to the x? A to the x is going to equal a to the x. So anytime you see this, it's going to be x. Okay, so another rule is the power rule, in which you have log base a to the x to the p. So here, you can just take this p here and just set it out in front. So p times log base a of x. The same can happen if you have a number out here. So say, for example, you have 5 times log base, 10 to the 25th. Say something like that. Here, you can just take that exponent, this number here, this 5, and just have 25 to the 5th power. This works either way.